We'll now focus on a problematic you used to have already in C, namely comparisons on structures. Remember, the comparison operator equals allowed you to make address comparisons. And from there, if two structures had fields with the same values, but different addresses, meaning two different instances of the same structure, you'd have a failing comparison. However, both structures had the same values. Of course, it's still true in C++. We'll be able to use member functions to add to our classes a compare bracket function that will allow you to make a structural comparison on two instances, and then check if they are equal or not. Let's get back to our friendly sample class as usual. We have the basic elements again. An integer underscore foo, a constructor accepting a parameter to initialize our underscore foo attribute, a little destructor, a little getter to get the underscore foo value, and a compare bracket member function taking as a parameter the address of a sample instance and make a comparison between the current instance and the one passed as a parameter. Let's see the code. Nothing very complicated, it's just logic. There's nothing new in this video. It's just about updating the test of structural physical equality. Understanding the difference to avoid surprises in your codes. The code of the compare bracket function is plain simple. Here we just get the address of a random instance, and we'll compare every time the value of our underscore foo integer between the current instance and the one passed as a parameter. As the underscore foo integer is private, we'll use the getFoo bracket getter to get the value from the instance that was passed to us as a parameter. So it's a very standard compare bracket function. If the current instance has a lower value, I'm sending -1. If it's greater, I'm sending 1. Otherwise, I'm sending 0 if both values are equal. From this lower function, we'll be able to code equals bracket, is greater bracket, is lower bracket, etc. We also have a little test main bracket to illustrate all of this. I'm taking two instances having different memory addresses, different stack addresses, and both built from the same value of 42. So we'll have two physically different but structurally identical instances. We won't have the same address, but the same content. To illustrate this, we have a set of tests. I'm going to check if the addresses are equal between 1 and 1, of course. That'll be our initial comparison. Then between instance 1's address and instance 2's address, we'll see the result. In the same way, we'll be able to use our member function compare bracket to check if instance 1 is structurally identical to instance 2. I hope so. And if instance 1 is structurally identical to instance 2. We'll launch a compilation to make sure all this is true. That's it. Let's run it. So we can see that both constructors were called as expected. And we can see that instant 1's address equals instant 1's address. So that's our initial comparison. Both instant 1's are physically equivalent. No problem. Then we have the physical comparison of addresses between instance 1 and instance 2, directly with the operator equals. We can see in this case that both instances are of course not physically equivalent. Then we can make a structural comparison. Here's the initial comparison between instance 1 and instance 1 that are of course structurally equivalent. They have the same internal value for their underscore foo variable. But we can also notice that instance 1 and instance 2 are structurally equivalent as well. But they are physically different. So this little notion of physical structural comparison is something simple that can be perceived naturally, but I wanted to take the time to explain everything so that everyone understands what it's all about. When we mention equality between instances, are we dealing with physical equality or structural equality? It's something that will be worth writing in your code. That's it. I'll see you in a moment on the next video.